Okay, hello everyone. I welcome you all in our lecture series on error function. In our previous classes, we discussed these three topics. That means lecture number 1, we discussed definition and characteristics. In lecture number 2, we discussed derivative of error function and complementary error function. In lecture 3, we discussed integration of error function and complementary error function. In this class, in lecture number 4, we are going to discuss some miscellaneous questions based on error function and complementary error function. Okay, so let us start. Okay, in this lecture number 4, we are going to discuss some miscellaneous question on error function and complementary error function. Here is the question number 1. So that error function can be represented as like this: 2 by root pi x minus x cube by 3 plus 1 by 2 factorial x to the power 5 by 5 minus 1 by 3 factorial x to the power 7 by 7 and so on. Okay, so here proof starts. We have to prove it. For that, we know error function of x equal to 2 by root pi integration from 0 to x e to the power minus t square into dt. Here t, x are the dummy symbols that we know. Also we know the Taylor series of e to the power x about x equal 0, or the so-called expansion of e to the power x about x equal 0 is nothing but your 1 plus x by 1 factorial plus x to the power 2 by 2 factorial plus x to the power 3 by 3 factorial plus so on. Okay, now we have to substitute this expansion of e to the minus t square in this integral, because we want to represent error function of x like this. So here I am going to substitute, instead of e to the power minus t square, this expansion or this series over here. Okay, so that implies error function of x is equal to 2 by root pi 0 to x. Instead of e to the power minus t square, we have to substitute this value, 1 minus here t square by 1 factorial itself 1. You just write t square itself, t square plus t to the power 4 by 2 factorial minus t to the power 6 by 3 factorial plus so on, bracket closed, integration with respect to dt. Here integration in respect to dt. Now we are going to integrate each and every term with respect to t. Error function of x will be equal to 2 by root pi. Here integration of 1 with respect to t is nothing but your t minus t square integration with respect to t is your t cube by 3. Then t4 integration is your t5 by 5. 1 by 2 factorial is there, 1 by 2 factorial into t5 by 5. Then minus t to the power 6 is your t to the power 7 by 7, 1 by 3 factorial into t to the power 7 by 7 plus so on. Here integration limits are 0 to x. Now we are going to substitute upper limit and lower limit. That implies error function of x will be equal to 2 by root pi. Here you can see, if I will put x over here, it will be x minus 0. So no need to put the lower limit, just put the upper limit and write down the answer. X minus, here you can put x to the power 3 by 3, lower limit is your 0, so no need to put the lower limit itself. X to the power 3 by 3 plus 1 by 2 factorial is there, this will be x to the power 5 by 5 minus 1 by 3 factorial x to the power 7 by 7 and so on. Hence proved. Hence proved. The question number 2 is given that we have to prove the integration of 0 to infinite limits e to the power minus x plus a whole square dx equal to root pi by 2 whole into 1 minus error function of a. Okay, so let us start to prove this question. This is very simple question. Okay, prove. Consider the given integral in the question e to the minus x plus a whole square into dx. To prove this one, this equal to this, let p small p equal to x plus a. That implies dp equal to dx, because here a is the constant. Now we are going to consider the new limits. For x equal to 0, if I am going to put over here 0, then p we can found a. For x equal to upper limit infinite, then p will be infinite, because infinite plus a will be equal to infinite. So the above integral will be, now the above integral will be, now above integral will be what? Integration changed. It was 0 to infinite, now it will be 8. Now it will be a to infinite. Okay, a to infinite e to the power minus x plus a we considered as p, e to the power minus p into dx. Instead of dx it will be dp, right? Sorry, here we consider p equal to x plus a, so this will be e to the power minus p square dp. But we know complementary error function of x is your what? 2 by root pi x to infinite e to the power minus t square dt. So instead of x, if we are going to consider a, then that implies complementary error function of a. I told that x, t are the dummy symbols. So instead of x, if we are going to consider a, then it will be written as what? 2 by root pi a to infinite e to the power minus t square dt. Okay, see, already we discussed in our lecture number in lecture number 1 itself, complementary error function represented as like this: 2 by root pi x to infinite e to the minus t square dt. Same thing I have been written over here. So instead of x, if we are going to consider a, so obviously the limits will be a to infinite e to the minus t square dt. And as t square is your dummy symbol, so we can write complementary error function of a equal to 2 by root pi a to infinite e to the power minus p square into dp. So consider this is your equation number 1. Okay, consider this is your equation number 1 and this is your equation number 2, right? So by comparing equation number 1 and 2, what we can write here? By comparing equation 1 and 2, we get, here you can see this integral we have in your equation number 1. So this much integral will be equal to how much? Root pi by 2 into complementary error function of a. That implies What we found by comparing equation number 1 and 2, a to infinite, e to the power minus p square dp is equal to root pi by 2 into complementary error function of a. One property already we have been studied about error function and complementary error function. This one, error function of x plus error function complementary error function of x equal to 1. So if I am going to consider this property, then complementary error function of a can be written as 1 minus error function of a, right? So this property I am going to use over there. So here complementary error function of a is there. Here complementary error function of a we have. So instead of complementary of error function a, we can write 1 minus error function of a. That implies 0 to infinite, sorry, a to infinite e to the power minus p square dp equal to root pi by 2. This can be written as 1 minus error function of a by using the property, by using the property, that is what, error function of x plus complementary error function of x equal to 1. Okay, so here we had to prove this one. From this integral we found this one, hence proved. That implies 0 to infinite e to the minus x plus a whole square. See, from here by considering this integral we found this integral, then by comparing 1 and 2 we found this much value. So obviously this value e to the minus x plus a whole square dx is equal to root pi by 2 whole into 1 minus error function of a. Proved. Okay, now we are going to go for our third question. In question number 3, it is given that find error function of 0 to 0.2 correct up to 3 decimal places. That means we have to find out error function of 0.2 by correcting up to 3 decimal places. Okay, here is the solution starts. In our question number 1, what we found? In our question number 1, we found error function of x can be represented like this. So instead of x, we have to substitute 0.2. That's it. So from question 1, we found you have to write like this. In your exam, you can write we know like this. Here we write from question number 1, we found what we found, error function of x is equal to this one, 2 by root pi whole into x minus x cube by 3 plus 1 by 2 factorial x to the power 5 by 5 minus 1 by 3 factorial into x to the power 7 by 7 plus so on. So to finding the value of error function of 0.2 by correcting up to 3 decimal, here you just substitute, put instead of x equal to 0.2. So that implies error function of 0.2 will be 2 by root pi. You have to just substitute and calculate this x 0.2 minus 0.2 whole cube by 3 minus plus 1 by 2 factorial into 0.2 to the power 5 by 5 minus 1 by 3 factorial 0.2 to the power 7 by 7 plus so on. So you just calculate with the help of the calculator error function of 0.2. You can found approximately you can found, see here, instead of pi you have to substitute 3.14 corresponding root over, and here 0.2 cube, here 0.2 to the power 5. You just calculate this one, you can found approximately value error function of 0.2 0.227. So this is your answer. In your question it has been given that up to 3 decimal places. So in your exam you have to write up to 3 decimal, that means 0.222. No need to write 7. Okay, I written over here, but you just write up to 3 decimal, that means 222. So this is your answer. So here in this lecture number 4, we discussed some miscellaneous questions belongs to error function and complementary error function. In lecture number 3 we discussed integration of error function and complementary error function. Lecture number 2 we discussed derivative of error function and complementary error function, and lecture number 1 we discussed characteristics or properties of error function. This is enough for physics honors university examination. I'll upload the note and I'll give the description link in the description. You just download the note and watch the videos of this playlist and prepare for your exam. Okay, so thank you so much for watching this video. Thank you.